Today's lesson is polynomials given zeros and a point. All right, let's start with what's the learning objective for today? I can write the equation of the polynomial in factored form given the graph and one additional point by solving for the leading coefficient a sub n first and then writing the zeros as a factor and adding the multiplicity based on if the zero crosses, bounces, or changes concavity with the x-axis. I can name the equation of the degree in words by looking at the exponent of the leading term. So let's just take a minute here and evaluate where we are on this learning spectrum. I am expert all the way down to novice. Okay, yesterday we talked about standard polynomial form and factored polynomial form. And each equation gives us different information. I know what the degree is. The letter I use to talk about the degree is n, and it is the exponent of the term of the highest power. If the degree is 1, I know I have a linear equation. The degree is 2, I know I have a quadratic equation. If the degree is 3, then I know I have a cubic equation. The degree is 4, I have a quartic equation. And I usually think of the singers for these. And if the degree is 5, I have a quintic equation. Well, my leading coefficient is referenced as a sub n. And the term for multiplicity, the variable I use is a script k. So this is a script k. So when the multiplicity is 1, that is referenced as a single root. When k is 2, I have a double root. And when k is 3, I have a triple root. So I need to know what a single double, and a triple root look like. So when I have single roots, so here's 4 examples of single roots. This is where I'm going, I cross the x-axis pretty straight. For a double root, I'm going to bounce on the x-axis. And for a triple root, this is where the concavity changes. So I'm concave down here and concave up here. So I cross and the concavity changes. Okay, so just reviewing that, let's get started. So what's our strategy here? My strategy is I'm going to write the equation of the polynomial in factored form given the graph and 1 point, and I want to name the equation by the degree. So the process here is write the general factored form of the equation from the zero and multiplicity of each zero. Substitute the point into the general factored form to find the leading coefficient a sub n. Write the final factored form of the equation. Name the equation by the degree. And then verify the degree and multiplicity of each zero. Do they match the graph? All right, so here's an example. given that I have point -1, -8. I want to find the equation here and name it by degree. All right, so I'm starting out by taking a look at where the zeros are. So I know that here, my 0 is x equals -2. Oops, x equals -2. Here, my 0 is x equals 0. Here, my 0 is x equals 3. All right, so I know, let's look at what the multiplicity is. So for the 0 here, the multiplicity, I'm crossing it straight, is 1. Here I'm bouncing. So I know my multiplicity here is 2. And here I'm crossing pretty straight. So I know my multiplicity is 1. So I'm going to add my multiplicities together. 1 plus 2 plus 1. And I get 4. So n equals 4 is my degree. So by name, I call that a quartic equation. Okay, so that's one part. All right, next, I am going to start writing the equation. So if x equals 3, so when I want to write this in factored form, I'm going to move the 3 to the other side of the equation. So this is going to be x minus 3. This is going to be x plus 2, because when I change the side, I'm going to just write this as x minus 0. When I change which side of the equal side I am, I change the sign. Okay, so I'm going to write my general equation. So I'm going to start out and write my general equation. So f of x equals, I'm going to solve for this leading coefficient. So my factors are x plus 2, and my multiplicity is 1. And I'm going to write this as x minus 0. My multiplicity is 2. And x minus 3, and my multiplicity is 1. I don't have to really write the multiplicity of 1. That's understood, but I'm just doing that for clarification. Okay, so now I'm going to substitute in the given